So we have a statement-based question here. So what I'm going to do is we'll divide this entire solution into three parts. One will be statement one, where we'll discuss the lift going up. Sorry, I think it's wrong. It's the other way around. It should be lift down, and the other where we'll discuss lift going up, and then as a separate topic we'll discuss statement two. Okay. So first, let's delve into the details of statement one. So what is given in statement 1? It says that an elevator can go up or down with a uniform speed. Uniform speed when its weight is with, well, I think it says weight is equal to the weight of the tension of the cable. So what are the key words to be noted here? So the first keyword is can go up or down. Why is it a keyword? Because it represents the direction. And the second keyword is uniform speed, which means if it is uniform speed, then acceleration is equal to 0, right? So let us take an inertial frame. So this is an observer here, and we have the building. There is a lift. There's a rope attached to the lift, and the lift is now moving. Say lift is moving downwards. Okay. So when the lift is moving downwards, let us now find out the various forces acting on this lift. See, what are the various forces acting on it? Let us list them. So the first force acting on it is definitely the force of gravity, right? The second force which is acting on the lift is the tension, right? And as of now, we don't have any other force. So let us mark these forces. Tension. What is the direction of tension? Tension, as we say every time, is always away from the point of contact. Maybe I can just write it over here. So tension is always away from the point of contact. Tension is always away from the point of contact, and this is the point of contact, and this is the object under consideration, which means tension would always be away from the point of contact, like this. Okay. So if I were to say mark tension over here, this will be the direction of tension. Okay. Now what is the next second force? Second force is gravity. And how is gravity acting? Gravity will always act towards the earth. Gravity will always act towards the earth. Now that we have marked all the forces acting on the body, the next thing is to draw the net direction of motion. So if we were to draw the net direction of motion, what is the net direction of motion here? Net direction of motion here is lift is moving downwards, so net direction of motion is downwards. Now, all those forces which are acting along the net direction of motion, which means all those forces which are acting downwards, we will consider them to be positive. All those which are moving upwards would then be negative. Okay. Now, by Newton's laws of motion, we have sigma Fy is equal to m into Ay. What is sigma Fy? Sum of forces in the y direction. How many forces are there? Two forces. What are the direction? One is positive mg. The other is tension, which is negative t. So we have plus mg minus t is equal to m into Ay. Right? Now, if we take sigma Fy is equal to plus mg minus t is equal to m into Ay, according to the question, the lift is moving with a uniform speed, right? It is moving with a uniform speed, which gives us that Ay is equal to 0. Ay is equal to 0. Ay is equal to 0, right? So, maybe we can just skip this step. So what is mg minus t is equal to? Mg minus t is equal to m into Ay, which is actually equal to 0, right? Which is equal to 0. And if mg minus t is equal to 0, what does it imply? It basically implies that mg is equal to tension. And what does statement 1 says? When its weight is equal to the tension of the cable. Weight is equal to the mg is equal to the tension of the cable. So statement 1 is true when the lift is going downwards. Let us see what happens when the lift is moving upwards. So, okay, this is not statement 2. Right. So now when the statement 1 is statement 1 is considered, and the case being lift moving upwards. Give me a minute, let me just magnify this explanation here. So the lift is moving upwards. All our observation remains the same, except for the change in the net direction of motion, right? So what are the various forces acting here? As we discussed earlier, the two forces acting here would be force of gravity and of course force of tension, right? Now, what is the net direction of motion? The net direction of motion is, I think there's a mistake here. It should be upwards, right? Because my bad. So the net direction of motion is actually along the positive y-axis, which is moving upwards. So if we say that the net direction of motion is upwards, then we'll take all those forces which are moving upwards as positive, and all those forces which are moving downwards as negative. So weight is acting downwards. So in this case, we'll take weight as negative. Tension is acting upwards, and therefore we'll take tension as positive. Now you may ask, why is tension in the upward direction? Because tension always will move away from the point of contact, right? Okay, so what will be the sign for mg here? Mg, the sign here would be negative, and for tension it would be positive. And as in the previous statement, we know that the acceleration here is also equal to 0, is also equal to 0. Therefore I can write that minus mg plus t is equal to 0, and therefore t is equal to mg, which makes statement 1 to be true. So statement 1 is true in both the cases where it is moving upwards and downwards, right? So that part is clear. Now let's move on to statement 2. So the statement 2 says the force exerted by the floor of an elevator on the foot of a person standing on it is more than his or her weight when the elevator goes down with increasing speed. So we have an observer in the initial frame here. There is another person standing inside the lift, and the lift is coming down. And the statement is making a claim that the force exerted by the floor, so this is the floor of the lift, on the foot of a person. Now maybe I can just write it down one more time. So the force exerted by the floor of the lift on the foot of the man, right? What is this force? Oh, come on guys, we've been discussing many such problems. This force is nothing but this is what we call as the normal reaction. Now, normal reaction, to be more specific, normal reaction on the man due to the normal reaction imparted on the man by the floor of the lift, right? So if we take the free body diagram of the man here, mind you, not the lift, if we take the free body diagram of the man here, how many forces are acting? There are only two forces acting on it. One, it is his weight which will impart it to the, okay, now you may get confused with the lift, so maybe I can just draw it like this. And what does this shaded region represents? This represents the floor of the lift. Now when he is standing on the floor, what are the various forces acting on it? Force number 1 is gravity, which will act downwards. Another force by which the, say for example, if he gives x newtons here, definitely the lift will give an reactive force which we call as normal reaction. So that will write it as normal reaction on man due to the floor, and then there is weight. But this lift is increasing speed. It is moving down with increasing speed. Therefore, what is the net direction of motion? The net direction of motion is downwards. And since net direction of motion is downward, we can say we can write that sigma Fy is equal to m into Ay. And this time, can Ay be 0? No, because it is moving down with an increasing speed. Now, what is sigma Fy? How many forces are here? There are two forces which are present in this condition. Which force will you take it as positive? All those forces which are moving along the net direction of motion will take it as positive. Therefore, mg would be taken as positive, and normal reaction is moving up, net direction is moving down. They are against, so we can write n as negative, which means I can write here that mg, right, plus mg minus n is equal to ma. Or in other words, this can be written as mg minus ma is equal to n. And okay, let me just write like this. So we have n is equal to mg minus ma. Now in this case, if we have to understand it in very simple terms, we put like this. What is 2 is equal to, say for example, 2 is equal to 5 minus 3? Very straightforward example. In this case, what is the meaning? It means that 5 is greater than 2. Compare it over here. What does it mean? It means that mg is greater than n. And what does the statement say here? Force exerted by the floor of the is more than. What is force? Normal reaction. So the statement 2 says that normal reaction is more than the weight. But actually, what is the case here? Weight is more than the normal reaction. And which is actually the other way around statement 2. So statement 2 is a false statement, whereas statement 1 is the correct one.